All right, chip of the day. Chip of the day, let's see. Chip of the day, who's the winner? Who's the winner? How about this one here? Let's pick this one. Okay, chip of the day is a 14-pin dip, but it's missing some legs. Okay, so it fits a 14-pin socket, but it's missing a bunch of legs. So what type of IC could that be? Well, you might guess, maybe it's an optocoupler. We need some electrical distance between their optocoupler would be a good guess. Or maybe it's a delay line. Sometimes delay lines just need an in and an out. You don't need all those other legs in there. Could be that. But this is a Electrol, and the only part number on it is an HP part number. In fact, they even put the little HP logo on it. And the HP part number is 0490-0915. So Hewlett-Packard oftentimes put part numbers on ICs and no one else could know what they were. Like, let's see here. Here's some parts right here I've got in a bag, and you can see that they have nothing but an HP part number on that. It's backwards. And so usually if it was a TTL type part, it would start with 1820. If it was a digital part, 1820 dash something. And if it was an analog part, it would be 1826 dash something or other. So anyway, you can go online, you can find cross references for what those cross reference to in a normal number. But this is a relay. And so let me show you a diagram of what this relay is going to be. And it's going to look like this, okay? And so it's going to have a coil that magnetizes the relay, actuates the relay, and then it's going to have a switch in it. And this switch is one of those glass reed switches. I'll put a picture in here. This is a glass reed switch, and if you get a magnetic field next to it, it'll close. Sometimes they're mercury wetted, sometimes they aren't, but they are all encapsulated. So if you have this nice glass encapsulated thing and a coil, you can just pot this whole thing in epoxy, right? And so that's probably just what's inside this thing. Now this particular part also has all these legs just shorted together, okay? They just look like that, right? So we don't know much about this thing, but we can measure the resistance of the coil, okay? And that's how I actually developed the diagram here. I measured the resistance of all of the leads and just reverse engineered it. But let's measure the coil here, and the coil is measuring 500 ohms, okay? And just from searching around and some experience, I know that that is a 12-volt relay, okay? So 12 volts, here, let's calculate it. 12 volts and 500 ohms, it's 24 milliamps, okay? So this thing takes 24 milliamps to operate, and it's going to be a normally open, single pole, single throw, right? So we can put our ohm meter on the connections of the switch, and then we can get 12 volts. Let me find 12 volts. Here's 12 volts. We can hook 12 volts up to the switch and watch it do its thing. So it's open right now, and if I put 12 volts on that coil, oops, and I'm not, my fat fingers here, we get 0.1 ohms. Very nice. And I don't know if these are very popular any longer. It seems like I don't see these in equipment very often. They seem to be quite popular back in the 1980s. So if you see one of these in an instrument, you might be confused and say, "Oh, that's some weird IC I don't know about." No, it's a relay. This one was built in 1975. Pulled it out of some piece of HP test equipment. Usually when I recycle test equipment, and something I can't repair or something that's not worth repairing, I'll pull the ICs out of it if they're on sockets and stuff. So this was on a socket. A lot of times these are on sockets because they are a failure point. Anything mechanical is a failure point, so these will be easily changed out. But yeah, there you go, chip of the day. It's actually a relay. I don't know what current capability it has. Usually that wasn't an issue in these things. These were mostly used for switching. Before there were analog multipliers and analog switches, you used a lot of these relays. That's probably why you don't see a lot of these any longer, because you would just use a modern solid-state device instead of a relay. But the front end of a DVM might have relay switching for different gain settings or things like that, or AC mode, DC mode on a oscilloscope or something like that. But yeah, there you go.